Can you hear me in the back? Yeah, thanks. Cool. I'm gonna get started because we're running a little bit behind, and I've got a bazillion slides that I need to get through. So if you're here for this talk, too bad. It's not the one that I'm gonna give. Sorry. I renamed it Smashing the Jars because I needed to come up with a way better theme. My slides were way boring, and this way I can incorporate Legend of Zelda memes. So who's played Legend of Zelda here? Awesome, cool. So you're all gonna enjoy this. There's something that's like, a lot of people think the main point of the game is to like save the princess and destroy evil, but it's not. It's actually to go around and like smash jars. And by smashing jars, you get healthier and richer. So at the end of this talk, you'll all see how you can be healthier and richer by smashing jars. But first I'm gonna talk about me, because that's why you're all here. Yeah. That's what I look like with about 1.5 pounds less hair on my skull. I did some security stuff for a while. I still do security stuff kind of all over the place. Right now I'm at Palo Alto Networks doing threat research. Recently I wrote some challenges for a few CTFs, so that's kind of about me. About this talk, I'm going to give a brief introduction to Java, JVMs, and jar. You're probably all really familiar with Java, so I'm not going to belittle it to death at all. I'm going to go really quick, like I said earlier. Then I'm going to talk about current Java threats. I'm not going to cover like malware that's focused on DDoS or exploits within the JVM. Yeah. Oh shit. Got a jiggle. Jiggle is a jiggle. No? Oh, I see. Sorry, guys. Off and on, not the other way. You guys are all smartasses. I love it. Cool. Sorry? That one? Yeah, the beautiful face. All right, enough fooling around. So then I'll talk about, like I said, Java, and then current threats that are built on top of Java, so mostly Java rats. I'll give some analysis and detection, like overviews, what tools I like to use, how I do what I do, and then I'll hopefully have time for a demo if I go fast enough. Okay, so Java basics. Java is a programming language. We probably all know this. It's object-oriented. A lot of schools use it to teach like computer programming. It's been around for a while. There's a lot of libraries, a lot of users. It's everywhere. 3 things that you need to know about Java: the JVM, the JDK, and the JRE. JDK, I'm not going to cover too much because it's like more for developing in Java, but the JVM is the piece of Java that you need to execute code along with JRE, which is like some runtime environment libraries and stuff like that. Something to note is the JVM, the software that you install to execute Java, is specific for the platform that you're running it on. So you need a special version of the JVM to execute Java on your Mac. You need a special version of JVM to execute Java on your Windows machine. And the cool thing about that is that because you have these, the JVM is operating system dependent, so that the compiled bytecode doesn't have to be. So any JVM will execute whatever Java you write. So you can write your malware once, and it can run anywhere the JVM is installed. Java is compiled to bytecode, so it's not assembly, which is nice because assembly is hard and it makes me think too much. So it's similar to Python, where you can sort of reverse the bytecode back into source code and actually go and read it, which makes it really, really nice for reverse engineering Java malware. This, can you guys all still see that? Cool. This is the reverse engineering spectrum of tribulations, or how hard or pain in the ass something is depending on what it's written in. So on the left, you see like pure source code. If you have source code, it's really easy to, well, pretty easy to reverse engineer depending on how well it's written. And on the right, like in my mind, the most difficult thing to reverse engineer is a service on a remote system that you have absolutely no visibility into, and you can just like telnet to, and that's it. Right. So Java's sort of towards the left a little bit. It's about as easy as .NET. It's not quite as hard as something like C++ or Delphi. So yeah. All right. So jar file formats. Java bytecode is compiled into something called class files. Class files are then stuffed into jars, which are basically zips with special purpose contents, and those contents are called resources. So you can put pretty much anything in a jar. It's a file. It's a zip file. But you need special things in there for it to be a jar, because you can't execute any zip as Java, right? One of those things, like I said, class files. I'm not going to talk about constant pools. If you're interested, come find me. We'll talk about those later. Manifest files are pretty important, so I'll get into those in the demo a little bit. And these are plain text files that contain key value pairs, kind of like HTTP headers, if you're familiar with those. And one of the really important ones that you'll see is called main class, which is basically the entry point for the jar. So if you run the jar from the command line, you don't have to tell Java what to execute first. It'll just go and look in the manifest and then execute that method first. Am I going too fast? I feel like I'm talking really fast. Okay, good. You guys all know this stuff? Perfect. So let's talk about Java threats, some basics about Java threats. There's a whole host of them. Some of them are more mature than others, just like every other rat. Things like Blue Banana are sort of a proof of concept, while things like JSocket and JByFrost are like really mature and well done, well developed. A lot of Java malware comes as a kit. So you've got this nice like builder that you plug in some configuration options, you hit make me a malware, and it spits you out a jar that you can go infect people with. And those builders will often include something I call stub jars, which are basically like blank template jars that whenever you put in your configuration options, that builder will go and rewrite a little bit of the stub jar and then spit it out. So if you write SIGs based on those stub jars, you can actually defeat a lot of the kits. A lot of different families will reuse common libraries. So I'll talk about that a little bit later, but one example is, why would you write a webcam like utility or library in Java if one already exists? If you're trying to write a rat that you can use to spy on people, just use whatever's out there. Java's got a rich ecosystem, like I said, and a lot of things that you want to do are already written for you. Whiskey. So the last thing about this slide, there's a lot of AV detections on VT with Java rats, and they're kind of generic. So in my opinion, there's something called JRat, which is a family of rat, also called Jackspot. And it's often really confusing if you look at a JRat sample on VT what the detections are, because like J could often stand for Java. A lot of AV vendors will just call any Java rat as JRat because it's sort of a generic name. So if you see JRat on VT, it could be generic, it could be a specific family. It's a pain in the ass to kind of decipher. And there's another sort of overloaded term called adwind, which could represent a whole host of different variants within the adwind family. And a lot of AV vendors will just call any of those variants adwind, which in reality they're not. Like, well, I'll get into it. Anyways, there's a handful of other Java threats that I thought were worth mentioning. I'm not going to dig too deeply into them, one of which is banload. It's a Brazilian banking loader that loads banking Trojans. Another one called just Java ransomware, which I found on GitHub, that was developed by, I believe, 2 high school Korean students. Not distributed in the wild. It wasn't fully written. It's just sort of a proof of concept. JDB, I'm not going to talk about. Sorry. I don't have enough time. It's a bind shell. And then JavaFog, which is a variant of an IceFog backdoor. So if you're familiar with the IceFog APT group, they targeted mainly like military contractors, government sort of type targets in East Asia. And Kaspersky actually found a variant of their malware in a jar that would call out to, that would call out to the domain that was actor controlled, so they knew it sort of belonged to this group. And it was written in Java, which, to me, it was the first thing that I saw that was like targeted, written in Java, so I thought it was worth mentioning. I'm not sure why they wrote it in Java, because if you look, here's a screenshot of the source, if you can actually read that. Down below, you can see the IceFog domain, and then up above, they're actually shelling out to Windows. So like, why write cross-platform malware and then use the Windows shell? I don't know. But They're supposedly APTs, so they have to know what they're doing, right? Yeah. Some reoccurring characters or commonly used things that you'll see across Java threats. This Java utils prefs thing is used all the time as a persistence mechanism. So if you ever want to store something or persist some piece of data in your Java malware, you use this library. In Windows, it uses the registry, and in OS X, it actually will drop a little file into the library preferences folder in a user's like home directory. There's a whole list of other commonly misused or used libraries. And like I said, a lot of malware will shell out and use this like runtime exec thing, which just takes the system shell and then executes a command. Again, don't know why, but whatever. So types of attackers that are using Java malware. Of course, you've got the skitties, the people sending mass spam campaigns, hoping to just get the most number of compromises possible so they can say, look at my cool botnet, look what I can do. I can DOS Krebs or whatever. You've also got financially motivated actors, which I would say are like half a step more technically competent than these skitties. And you have examples of that, like people using Banload to target end users of banking software, as well as Kaspersky wrote on a handful of compromises that they did during assessments in Singapore for banks, where they found Adwind actually inside of banks. So you sort of see like front end and back end being targeted. And then the last group, I don't want to call them APTs, but they're like surgical actors, right? They're not just going after mass numbers, they're going after something specific. And a handful of examples, one of which I mentioned, IceFog. Also something called PackRat, which was a group reported on by Citizen Lab in 2015. They used two different kinds of Java Trojans, and they were targeting political dissidents, journalists, those types of people in Latin America. And then also the Manuel campaign, which came out, EFF reported, I think, at Black Hat sometime this year, about the Kazakhstan government targeting similar types of people in Kazakhstan. And they use JRAT, which isn't the generic term, but the actual family. Okay, so audience participation. Who can name something that comes in a jar? Cookies. Rupees, cookies? Mayonnaise. That's a good one, yeah. Anything else? Sorry, moonshine? I would have also accepted hearts, rupees, bombs, other items, or malware. So these are all the families that I could find. And it's not a ton, but let's talk about them. On the left, I have approximate soft dates of when they first emerged, and I base that on the first VT submission I could find, or the first forum post I could find selling the rat, or the first like code commit in GitHub, or the first blog post detailing the family itself. There's a bunch of them. I drew some boxes around families. So this Frutas through J. Bifrost, it's all written by one guy. I'll talk about it a little bit later. JSpy and OS Celestial are also related. I believe OS Celestial, it hasn't been talked about, but OS Celestial is basically JSpy with a few extra features. If you look at like the libraries used, or the config file format, or the builders themselves, or the domains that are selling these, their registrant information, it just all overlaps. So I'm guessing very confidently that these are related. And then there's also two versions of QRAT. I'll talk about both of those. Here's a slide with another box, but this box goes the other way instead of long ways. This is a hot dog box instead of hamburger, right? You guys understand. And it circles the families that came out in the past year and a half, which is about a third of the families that I could find. And I think this is kind of telling, like, yeah, Java malware is not used very often, but over the past year, it's like sort of, I wouldn't say exploded, but there's a lot more stuff coming out. It's doing this. So I think that's a trend. Okay. Are there any questions? We're at like a third of the talk. I don't know. What time is it? Jeez. Okay. No questions? Let's keep the train wreck going. So Fruitus, this is sort of the driest section, so I'm going to go really fast and hopefully just skip a lot of this to get to the demo because that's the exciting part, right? So Fruitus was originally a proof of concept, came out in 2012. It's one of, it's not the oldest, Adzoc's the oldest, but it's one of the granddaddies, right? It became popular around 2012, July. Plain text configuration file. It used a lock file similar to Adzoc. I wouldn't be surprised if whoever wrote Fruitus was looking at the Adzoc source code to kind of mimic what they were doing. Here's a screenshot of the lock file from the source. Again, it used this runtime exec thing, so not very smart, only ran on Windows. After that, the dude that wrote it actually came out with another version he called Adwin, which was a little bit better. Came out in 2013, just sort of a rebrand. It supported Android. Started using some obfuscation. Here's a screenshot from the manifest file. You can see in the created by header, there's some goofy stuff in there. It also used really long obfuscated class file names. Yep. After that came something called Unrecom or Unrecom, I'm not sure how to pronounce it. Basically another version of the same rat with a few extra features added. Here's a screenshot of the server class for an implant that I found. After that, it got rebranded again because this guy really likes rebranding things. Some additional features including sandbox detection, anti-analysis, and aleatory obfuscation baked in. And something that I thought was kind of cool, you probably can't see this, so just close your eyes for a minute and I'll just talk about it. There's a lot of implants, alien spy implants, that are using class file names that are really, really long. So here I'm just piping one of the class file names to a word count and doing a character count on it. And if you can see in the first row, there's 298 characters in one of the class file names, which if you try to unzip a file or a jar with a file name that has 298 characters in it, a lot of operating systems will just kind of poop their pants because there's a max limit at 256 characters, and it's like, well, I don't know what to do with this. Great job. So kind of an interesting obfuscation technique. Here's just a screenshot of an alien spy implant using aleatory. You can see the aleatory X demo string in there. And hopefully in the demo, if we have time, we'll see how to deobfuscate that. Here's a screenshot from this cool product that we sell at Palo Alto that I'm not going to talk about too much because it's not commercial, but you can see some of the commands that alien spy implants will run. So they'll just like execute a bunch of task kill commands with common analysis tools like Process Explorer, Process Hacker. So if you're tearing apart one of these samples and you're actually debugging it, like just be aware that all your tools will die. After that, the dude came out with another rebrand called JSocket, and he sort of switched things up because he got really tired of being taken down and sort of his domains, his software being cracked. So he switched to a software as a service model where you bought software from him, and then everything would go through his like central domain, which made it really easy to take down the whole everything using JSocket. Again, kind of dumb, but Kaspersky estimated, and I don't know how they came up with this, that he made a boatload of money and sold to a boatload of people. So good for him. And JSocket supported OS X. And here's a screenshot of me running a implant on OS X and the JSocket implant moving itself to a hidden directory in the user's home folder using some weird random created name. And then here's a screenshot of JSocket adding itself to a launch agent using a plist entry on OS X. You're probably sick of me saying this, but after that he rebranded his rat again into something called JBifrost, which came out earlier this year. It was talked about, I believe, by Fortinet. And something interesting that it did was it used serialized decryption keys in the implant, and it's the only family or variant that I've seen do this. So if you just look for jars that are kind of suspicious and they have serialized keys in them, it's probably this. Here's a screenshot that I stole from Fortinet, thanks guys, of the JBifrost interface as well as the JSocket interface. And you can tell, like, this guy just likes changing names a lot. They're like the same thing. And if you looked at Alien Spy, it's like the exact same. So ADZOC, it's actually the oldest one I could find. It came out in 2010-ish, which was like, I was like 6. There's a free, a paid, and then like an ultra paid version. I'm not sure what the difference between any of them are, but this PackRat group that I talked about, reported on by Citizen Lab, they actually used ADZOC to target quite a few people. It's still around, last time I checked, and last time I checked was a few months ago, so you might want to check again. But it's sold by some guy who's claiming to be from Bolivia, and he's got a Twitter profile, so tweet at him, see if you can get a nice, see if you can bargain with him, like haggle. Like how much can I buy this rat for? I just want to see what he says. Like I said, similarities to Fruitus. Yeah, let's keep it going. The free version doesn't run on Windows, but it does include a plain text configuration file that you can just open up the jar, pull out, and read. So you can see exactly like what the C2 is, what the password they're using is, all that good stuff. And it uses a lock file just like Fruitus. Here's a screenshot of the dude's website where he's selling his stuff. So you can go there and look at it. The next family is called Blue Banana. It's kind of boring. I'm not going to talk about it too much. It uses a password when it does like C2 communications that you can configure, but you can rip out the config and look at the password really easily. If you check out the about from the builder, it has greets to like hack forums. So kind of a skitty rat, not really used too much, but it's still floating around VT a lot, so worth mentioning. Another one called Crimson. Similar, pretty old, not super interesting. Something that it did that was unique was it dropped settings files into a SQLite database to disk up until version 2.1. And here you can see me running it on OS X, dropping its psettings.db database. Something cool about this rat is when you run it, it has debug configuration information spit out by default. So here's a screenshot you can't see of me running it on Windows and on OS X. The next thing's called JCage, came out in 2013. Again, I'm not going to talk about it too much. It does use something kind of cool in its implants. It uses WMI to look for AV software installed, and then I believe it goes and tries to kill it. But it's also Windows specific, so pretty lame. QRat is the next family, which the first version emerged came out in 2015, and it was, who was it reported on? I don't remember who reported on it, but it was a good report, whoever it was. Great job, guys. And it has this complex like 3-stage loading sequence where it's got one jar that will like unpack and load another jar that will unpack and load another jar. It only ran on Windows, so somewhat lame. Give them some props because of the cool like 3-stage loading thing. But they came out with a second version that was actually used to target US visa applicants in Switzerland over Skype, and it runs on Macs too. The difference between version 1 and version 2, besides running on OS X, so here's a screenshot of version 1 not running on OS X. And then here's a screenshot of version 2 running on OS X. The main difference is that the second version will actually go out to this corelax.com or .net, I forget what it is, and download all the jars that it needs to run, like all of its runtime libraries. So if you see something beaconing to that domain, you definitely have like a compromise on your network. Another family, JRat, that has that name that often is used for generic detections. Most of this rat is open source and on GitHub, and you can go download it, and its auxiliary tools, and its uninstaller, and everything like that. Similar to all the other rats, it's decently written. It's kind of old. It does have cross-platform support, which is kind of cool. Just like every other rat that runs on OS X, it's written in Java. It uses plist entries for persistence. So you're probably really sick of seeing plist screenshots. But The next family is called JFECT, and the only thing really worth mentioning about JFECT is the fact that it has two different C2 communication mechanisms, one of which was HTTP, and or IRC, sorry, getting ahead of myself. So here's a screenshot of it doing some C2 over IRC on Windows XP, and here's a screenshot of it using HTTP post method on OS X. And in both cases, it's kind of easy to spot and easy to sig off of because it's not a very good protocol, but yeah, whatever. This is a screenshot of JFECT, again, using a plist entry on OS X. Yeah. The next family is called OmniRat, and OmniRat is probably one of my favorites, so I'll talk about that one a little bit. It came out in around 2015. It's one that you can buy, and the reason that I think it's really cool is it has multi or cross-platform support for both its controller and its implants. And it also supports Android. So you can control OmniRat implants running on Android phones from your Android phone. And you can also spread your implants via SMS, which I thought is kind of novel and kind of cool. So like I can send all my friends who have Androids a text from my phone, compromise their phones, and then control them also from my phone. Something not so cool about this rat is that it was really easy to reverse engineer. It doesn't use any obfuscation, and it has hard-coded configuration files in it, hard-coded configuration options in its implant. So like here's an example of an OmniRat implant with a hard-coded IP address. And the C2 protocol that it uses is actually just passing around Java serialized objects. So it's kind of weird. I've never seen that before. So if you see Java serialized objects being passed around on your network in the clear, it might be this. It could just be another Java application. JSpy and OS Celestial. Let's see, what's interesting about these guys? They both have similar features. They both overlap beacons with those two domains. A lot of this stuff is like, you see enough of these rats and you're just like, oh, they all kind of taste the same. Like if they all walk and quack like a duck, like, okay, this is gonna taste like a duck too. So here's a screenshot of the JSpy website that you can buy the rat from. And again, uses plists for persistence on OS X. The next family is something called Ratty, which was fully open sourced on GitHub up until about a month ago, until the guy took it down because he noticed that people were actually talking about it. It used a pretty simple XOR mechanism to encrypt its configuration file, easy to undo. We saw this being actively distributed pretty much through April and May to a bunch of our customers. And then, like I said, it disappeared from GitHub a few months ago. It's probably still out there. He's probably still selling it, but he's not doing it in the public anymore. I did manage to get a screenshot of his Linux support in his implant, which is a bunch of comments with nothing in it. But his Windows support was really good. And here's some session data, like I said, from April of this rat actually being distributed via emails. So you can see some email subject lines and file names that people were using to distribute the rat. I went over those pretty quick. Are there any questions on individual families? I'm trying to rush so I can get to the fun stuff. Yeah, what's up? No, but it should. It would get way more attention in my talk if it did. His question was, does JK use Nicolas Cage memes? He should. All right, I'm gonna keep going. So some common behaviors that we saw amongst all these families that I talked about. A lot of them use obfuscation or like cryptors or packers to like try to hide themselves. A lot of them will use anti-VM or anti-analysis techniques, like trying to see what AVs installed or killing analysis tools while they're executing. And a lot of AVs, at least from what I've seen, I don't work at every AV company, so I don't have a great, perspective into this, but AVs can definitely determine if these jars are good or not, good or bad, but they have a hard time determining like what family they are or telling you like what kind of rat it is. And similar to every rat ever written, these Java rats use like 3 steps while they're executing. The first one is to typically hide themselves, and they'll move themselves into a randomly named directory or in a hidden directory or something like that. And then the next step is to persist. So in Windows, we see a lot of these rats adding themselves to startup folders or places in the registry. Like I mentioned on OS X, basically every Java rat is using plist files. And there's a great tool called Knock Knock that you can run on your Mac to go and look at all of the places where plist files are and see if you have anything suspicious that runs at startup. And then lastly, the rats will beacon. And as we saw, those beacons vary between families, but there really isn't a point to a rat if you can't communicate with your controller. So aleatory and ZKM are probably the 2 most used obfuscators that these families are using. Aleatory is by far the most popular. And it's a big pain in the butt the first time or the first few times you look at it, but once you get it down, it's pretty easy to be like, oh, that's where it's doing. It's like deobfuscation. Let's just rip this out and do this other thing with it. And there's also some automated tools that help. I'll talk about those during the demo. There's a handful of other sort of commodity packers, like this jar protect and jfuzzle that people are selling that I don't know why they're selling, because it's basically just like XOR. But hey, if you can make money. 2 tools that I really like to use that are worth mentioning. One's called JWScan. It's, I think it only runs on Windows. And what it does is it will scan PE files for jar signatures. So it'll look if there's something in the exe that will eventually call java.exe. There's probably an embedded jar in that PE, right? So the PE is probably going to drop a jar and then execute it. And there's something else called jar diff, which is a nice little Python package that's part of, what's it part of? Java utils or Java tools or something like that. That's the name of the library. And what it will do is it'll go through 2 different jars and tell you the diff between all the resources within those jars. So it's pretty helpful if you've got one jar that you know exactly what it is and another jar where you have no clue what it is, you can run sort of diffs against 2 jars. So deobfuscating jars, once you've found your jar, whether it's in a PE or you've diffed jars and you can see there's some type of obfuscation going on in there. I would say all of the implants that I've seen that use obfuscation have the deobfuscation logic within them. So if you hunt around long enough, you can find it, sort of wrap your brain around what's going on, and then re-implement the deobfuscation in Python so that you can deobfuscate the jar yourself. And there's also something called conditional breakpoints that you can set in Eclipse, which is a IDE for Java, and actually debug jars, which we'll do in the demo. This is the tool that I was telling you about that's up on GitHub. If you look at jar implants, this is definitely something that you should need to use. It handles a lot of deobfuscation automatically. You just like run this with your jar, feed it a couple extra parameters, and it'll try to deobfuscate as much as it possibly can for you. Cool, looks like we're on time. So, some analysis hints for OS X, like I said. P-lists are pretty much all you need to know, but there are a handful of other ways to persist on OS X. There's a great talk that was given at this Black Hat or a couple Black Hats ago that basically details all of the ways to persist on OS X. And I've got these numbers next to words in my slides. I've got like 2 long slides at the end of this with a bunch of references. So if I talk too fast or you don't understand my Zelda memes, go back and read the slides and go reference those links. Other tools on OS X, dtrace, especially with JVM hotspots, because a lot of times dtrace will be way too verbose. If you're running something in Java, it'll spit out basically everything the JVM is doing, With JVM hotspots, you can ask for specific things that the JVM is doing, which is kind of cool. Like I said, knock knock. On Windows, you know, your typical things you'd use, procmon, redshot, process explorer, that kind of stuff. And again, similar to other rats, registry keys, LNKs, and startup folders. You guys are probably familiar with that stuff. There's one tool that is really useful to some people. It's not to me, but it's pretty cool and it might be useful to you, so I'll talk about it. It's called bytecode visualizer, and it's a plugin for Eclipse that will actually give you an IDA-like graph view of Java opcodes for a jar that you're debugging. I'm not an expert in Java opcodes. I can't like read them and tell you what's going on, so this isn't super useful for me, but if you are, this might be useful for you. The number one tool that, if I'm going to look at Java malware, has to be is this thing, Java Bytecode Viewer. It's written by a guy that actually just wanted to cheat at Java video games, which is kind of cool. It takes like 3 or 4 different class file decompilers and wraps them in a nice GUI so that you can sort of switch between different ones, because a lot of times a jar will decompile with one decompiler, but it won't work with another decompiler, and it's kind of a pain to set up a bunch of different tools on one system. So this is like a nice all-in-one little package. Something else that you should be aware of called rat decoders. I'm not going to get into it too much. It's up on GitHub. Go check it out. It basically is a handful of scripts. I think it's like an official framework now. It's a little more modular that will rip out config information from different rats, not just Java ones. So it works with most of the Java wraps that I talked about today. Some things to be aware of if you're going to hunt or do any kind of analysis on these things. Jar rules based on resource file names within jars for finding new implants is, it works really well, except when those jars are obfuscated. So if you can get to the point where you've deobfuscated the jar, you can run YAR rules on it and like figure out what it is right away. Another thing called jar and jar loader that you should be aware of if you're going to do this analysis is jar and jar loader is something that will replace the main entry point in your manifest with another jar, and that can be a jar on disk, a jar remotely somewhere that can be downloaded. So if you're not aware that that can happen, it can be really confusing. It was for me when I first encountered it. And the last pitfall that you should be aware of is that manifest files are not required for jars to execute. So when you run a jar from the command line, you can tell it the entry point, and it will just ignore whatever's in the manifest. Or if there isn't a manifest in there, it'll just run that. So again, something to be aware of. Some key takeaway items. Get it? Key? Yeah. Java rats, they first started coming out around 2010. They're not really popular, but like that slide showed, in the last year and a half, we've had a pretty big increase in different families and variants. They're used by a whole like spectrum of actors, from very surgical to don't really have any clue what's going on. And if you look at the tools and the techniques that I mentioned in these slides and the references at the end of the slides, you're really good at this, I promise. And if you do this kind of stuff, or you're interested in it, reach out to me or come talk to me. I'm more than willing to trade YAR rules, configuration, extraction scripts, tips, whatever. So thanks DerbyCon, thanks everyone for getting up this morning and coming to see my talk. Thanks all these cool people for being really awesome. I'll take questions, but I think I have time for a demo, so let's do that first. This is going to be interesting because I can't see what's over there. Who knows the shortcut for like changing your display stuff? Anyone? Display. Mirror displays. Can you guys see what I'm doing right now? Oh yeah. Where's the X button? Spacebar? Enter? The files are in the computer. Go away. All right, there we go. Oh, everything's really small. So what I'm going to do is I'm going to take I think it's a JSocket implant. It's this file right here. This is malware. And we're going to look at it, and if I can figure out things. Oh, here it is. So the first thing I'd like to do when I'm looking at jar implants is open up this bytecode viewer thing and decompile it and try and look at the source. And bytecode viewer is really awesome. I can just open it up. And the first thing I'll look at is in the manifest what gets executed first, which is this main class file. So let's go look at that. Oh, it's ugly, right? So let's try maybe a different decompiler. Oh, God. Okay, so you can play around with this stuff, and you can see, like, it's terrible. What are these things? Who knows? But I kind of cheated, and this is a bit canned, so I know it's packed. No, I don't. Who needs updates? So what I'm going to do is I'm going to unpack it using conditional breakpoints in Java. So the first thing that you have to do is create a new Java project. Am I doing something? We're going to name it Crappy Wares. And you have to include an external jar, which is the implant. And we can see that it's still the same jar, you know, nothing up my sleeve. Open up the manifest file, it's still got that same entry point. What you can do is go into the Java runtime and set a breakpoint on a specific method that gets called by this malware to unpack itself, which is used by a lot of malware that's packed, at least Java malware that's packed. And it's called this. And what this does is it's a method, or it's a class that basically takes a section in memory and then turns it into like a jar. So if you think about when a jar is unpacking itself, it's going to do some math or some manipulation on some data, eventually have a full jar in memory, and then execute from that memory. So what we're going to do is when it gets to that point, take that memory and just dump it to disk as a jar. And I should have breakpoints set somewhere already, because I cheated. Who's used Eclipse before? Anyone? It's kind of buggy. Like it's nice, but there's some weird things that I found with it. Like I have this breakpoint set. I know it's set, but for some reason it won't show unless I like restart Eclipse. So let's see if we can find it. Alphabetical order. Yeah, okay. So we can see the breakpoint's now set. For some reason it wasn't before. And here's the code that it uses. Basically, once it reaches this condition, it'll stop and execute this code. And all it's doing is getting the arguments for jar input stream, the call for jar input stream, identifying the size of what's getting passed to it, and then just writing it to disk on my desktop for me. So let's debug this. I'm going to have to, sorry, bear with me. So there's two types of jars. One's an applet, one's an application. An applet gets run in a browser, and an application is like standalone. So we're going to include those, tell it the main entry point that I want to execute, and then hit debug. And it should give me a nice, yeah, cool. It's a nice pop-up. It'll drop me into the debugger. And I don't really care about it from here on out because it's written this cool unpack jar for me. So we're going to open that up in our decompiler and look at it. So you can see everything's been sort of renamed. It looks a little bit nicer. We open the manifest. It's got a new entry point. We can go there and check it out and hopefully just read it. Uh-oh. Try a different decompiler. Cool. So if you've looked at these things long enough, you can notice that like these are still really weird class and method names, and these strings are not strings. So this is actually aleatory. It's a pretty common obfuscator used, and it's still sort of a pain in the ass. I'm not sure where the deobfuscation code is located, but like you can't read anything that's going on. So lame. We're going to use this tool called that jar decompiler thing that I was telling you about. And what it does is it's going to read in that jar that we unpacked from memory, write to a new jar on disk using an aleatory transformer to decrypt the strings. And you have to feed it the version of the Java runtime that you want. So we're just going to run that. It's going to spit out a bunch of things to screen that I don't really care about and then tell me that it didn't work, but it's going to lie. And it really did work. And then we're going to go look at that unpacked, unobfuscated jar. So new jar. If I can figure this out. And again, we have the same entry point, but this time we should be able to read the strings. And yeah, you can. So you can see this is unobfuscated. You can tell exactly what commands will be run, things like that. And I believe one of these has a cool user agent that we could then go write a signature off of. Yeah, so you can see here like all the C2 like HTTP headers in the clear. So at this point, you've gotten all the way to the left on the trials of tribulation where you just have source code, and it's really, really easy to reverse engineer. So now, with that, are there any questions? Sorry. Later on. Yeah, go ahead. So the question was how can he contact me? I'm on Twitter. I can give you a business card. You can email me. We can talk after this. I'll be here for most of the afternoon. Yes. I haven't found any. So if you only execute signed jars, that's probably a pretty good strategy. Yeah, what's up?
With the jar loaders that you referenced, do you see anything that's like being the next explosion? Have you seen anything to do with jar explosion?
I haven't seen anything like that, no. It could be misused very easily, right? Where you just have jars just spit out all over the place, just like kind of spray the disk with jars. Anyone else? Cool. Thanks for coming, guys. Appreciate it.